Hello. Alright, we are gonna code some more of these examples for the engine. I've actually got one specific thing that now I want to do. Since I was doing the SSE and AVX programming, I was looking at CPU ID flags, and I noticed that the next instructions here, hold on, what is it? The AVX2 AVX512, it's all in the extended feature flags. So one of the things that I want to see is if I've got this CPU ID with the level here, I should be able to call level 7 excuse me, I have to sneeze. I should just be able to call it with level 7 EAX level 7, and it should give me these. So, let's try it. Anyways, I'm gonna actually make an example for CPU ID, I think, that just prints out what CPU features are available. I've got RD Rand, it's vector extractions. Oh, I may want to check for AES. That's useful. Ooh. I might want to add direct cache access. I think I might add these while I'm here. Alright, let's print these features. Alright, then we're gonna test support. Yeah, I'm in the macro. Alright, let's try this. Good check if MMX is supported. Might have got these flipped around. Yeah, I did. Here we go, okay. MMX available. Alright. Now we're gonna print out basically all of these. Yeah, I'm gonna add more to that. Oh, a new line. Okay, everything's available. Alright, so this right here is the number of flags. 1, 2, 5, 6, 12. So which ones are we gonna add from here? Check for AES. What was the other one? I think it was DCA. 25. Yes. Direct cache access. Hey Scallywag, I'm adding more feature detection to my CPU ID functions here. I've got a bunch of macros for declaring helper functions for these. Stream is the best. I wish more people did stuff like this. Well, this will all be open source soon, so maybe more people will. So this example literally just lists what features your CPU supports. It calls this assembly instruction. This is something a lot of people don't know about. There's an assembly instruction, CPU ID, gives you literally identification bits for the features in your CPU and gives you a way to identify CPUs. So DCA is direct cache access. It isn't really useful for most people, but it is sometimes. And AES encryption is actually super useful to a whole bunch of stuff, so really nice. Let's see. Oh, direct cache access isn't supported. AES is available. You can return on CPU event. Tracing like cache. Counting cache hit / misses? No. I mean, I have, but I wasn't really worried about that. I was just like debugging and stuff. I follow keep it simple stupid. In that like there's ways you can write code small and concise that it naturally is good for the cache. But yeah, I was thinking about that actually when I was writing that code back here for the sine transform. These vector instructions are actually super big, like 16 plus bytes. So this whole thing ends up being like a decently big chunk, and I was thinking that jumping, when the assembly jumps for these if statements, it's actually so big that it's going to load it in from the cache, and that if you separated these to different functions, it would basically only cache the ones you're using, whereas like with this it'll load in and cache all of it even if you're only using one. But yeah, it's so complicated. So, one thing I'm looking at is, will this even just work? You know what, screw it, let's just try it. So, do extended feature support. Running a profile tool and wanted to figure out how to actually calculate hit ratio. Going to a library called PAPI. Yeah, wait. Does the Intel virtualization automatically do that? Alright, so this should be... Okay, so this up here, where we were reading from last time, feature information, doesn't say it here, but it's EAX, oh it does, EAX equals 1. It's the thing you can ask the processor to do. Oh yeah, that's actually probably one of the things right here. And cache topology. This might be it. Anyways, the level is basically what you feed into EAX, so these values right here are from where is it? CPU ID 1. So this is calling it with EAX equals 7 for down here, and I think it automatically sets ECX to 0, so this will hopefully be correct. That's the one thing though, is there a printf binary? Because that's what I need right now. Gotta do it manually, okay. Anyways, I'm gonna loop through these CPU ID bits. I'm gonna print out the raw binary for it because that's the easiest way I could think of right now. Okay. So there's 128 CPU ID bits. They're in 4 32-bit integers. So samples that integer with I divided by 32, and that samples the bit using the modulo. Yeah, modulo. Modulus? Yeah. And then it prints those out one by one. I'm gonna print out a giant list, I just realized. So screw it, let's do it. Extended feature support. Oh shit, this is in Little Endian. Look at this. Okay, look at this. This is so interesting. I never realized this before. I don't know how I... Actually, I might have realized this and forgot it. So this 3 right here is the byte. Or sorry, this is the integer. And then this is the bit offset in the integer. And so MMX is the first one. you can see, where is MMX? Right here, 23 of the first bit. And then you can see the ones over here for 2, it actually goes like backwards. Page 7 of Windows menu, you can see the processor will tell you stuff like OLC. This is branches. Oh yeah, Hyper-V, okay. Hyper-V is like virtualization, right? And it's not really derailing, I think it's actually kind of related to this stuff. Worrying the CPU's features. So this isn't EDX, this is ECX. Let me check this. CPU ID. Unix CPU ID. Alright, that software, that Intel page won't load for me. I don't know, reading in chunks of 16 bytes, lower 32 bits of the file position is used as EAX, the upper 32 bits is ECX, the latter intended for counting bits. Okay, how does that compare to the Windows? Azure browser doesn't like PDF. Oh yeah, it actually... It's weird, Twitch isn't using my default browser. The lower 32 bits of the file position. I think that's not what I'm looking for. Linux Red Hat CPU ID. Linux. No, that's the console command. Oh, it's get CPU ID on Linux. Okay. Wait a minute. EDX32 EAX. Contains the information returned in EAX, EDX, CX, and EDX. EX and ECX. Okay. So it is in little endian, kind of. Let me make sure the Intel CPU ID matches, or the Linux CPU ID matches up. Built in. What are you wondering exactly? So this Windows function of the CPU ID returns EDX and ECX in the last 64 bits. And I'm wondering if I'm trying to make sure the Linux version keeps it or is the same. But I'm actually finding out the Linux CPU ID here, or the GCC CPU ID. Trying to find out if it has the same, but I actually can't find documentation on this. I just finding this GCC mirror. And its highest input value. I'm also trying to find information about where it returns the registers. ECX, EDX. Okay, yeah, it does it in the exact same order. EAX, EBX, ECX, EDX. Okay, I'm gonna rename these to what they are instead of data. Make this a union. Actually, screw it. I'm not going to overcomplicate this. Part of overcomplicating this is creating a struct called CPU ID bits when I could just do a uint32 or like that. Multi-versioning. Do you know if there's a version for Microsoft Visual Studio? Because that's part of the issues. I'm not just using GCC. Also, part of my thing is I don't know how it checks. Like, do you think each function call it checks if the CPU architecture is supported? Have you considered just using CLang? No. Well, yes, I've considered it, but I just really use whatever works, and for me, Visual Studio is what you can download and just works. Sadly, only GCC. Man, I would be surprised if Microsoft Visual Studio doesn't have a version. It does runtime polymorphism. Select all the best SMB family. Oh man, so that's part of the thing. Is I like to just know that there's a single boolean that happens at the specific point that I have optimized it to check at. And there's stuff where, like, yeah, I know what the best size is, and I don't expect the compiler to know. Like, there's stuff with that sign transform where there's no way the compiler's gonna know that it only becomes more optimized after, like, 8. Still implement it yourself. I know, but it automatically selecting which function to pick is part of the thing as well. Alright, so I'm thinking about this. So if right now these is the specific CPU ID bits, so the difference is the extended flags I'm not setting this right because I moved this. OSX save is now 11. Not 9. Okay, so this gets the CPU ID level 1, but the new features like AVX2 and AVX512 are on level 7 ID bits, so I have to get the extended features as well. So I was gonna do like a CPU supports underscore extended because it uses a different set. But I'm actually thinking now I can combine it into this same array of flags, because it's literally just a list of flags that I initialize once when it calls this CPU supports. This is EDX, ECX, EDX. Yeah, I can do this. I just need to create a version of this on FSF. Oh wait, no, I can just reinitialize BID with level 7. Okay, I got this. Let me make sure, I just changed up a bunch of stuff. Let me make sure it still compiles. No, that's what I thought. Oh, that's a lot of errors. That's what happens when you change something in C. Alright. C return array. I'd probably just really stupid, but return array functions. C return constant array. Oh man, I remember this. You have to put it in a structure. Yeah, that's what I thought. Okay. You know what? And it's actually nice. Oh my god. Okay, wait. Let me just hold this undo button and just undo everything I did. I think I had a good idea before putting this in a union. Let me just make sure. I don't fully understand unions. I know this sounds fucking crazy, but like, what describes where the breaking point is? Call it a breaking point? Like, untagged unions are expressed nearly like structures, except each data member begins at the same with data members as in structures. So do I need to put, like, if I wanted to do uint EAX, EDX, ECX, EDX like that, so it becomes the size of the largest member. Yeah, if I did that though, would EBX, ECX, and EDX be one after each other? They should be, yeah, I believe that's how it works. I can actually test this as well, I think. And test dot. Oh wait. Just need to make sure I have this right. EAX, EBX, ECX, EDX. Yeah, okay. I'm just checking the offset. Versus negative. Oh, that's wrong. That's supposed to be up here. Oh, wait. Ooh, it didn't work. One versus 0. It's not offset. Shit. I think I need to put them in an unnamed struct. C union struct. Combine int. Union multiple members. Alright, so if it has anonymous scope, then I believe I can do like this. Oh shit. Boom, there we go. Alright, I got it. Oh, it's good to figure this stuff out. Okay, so now we're also going to get the advanced features. So to do that, after getting all these normal features, we're going to call the level 7 to get extended features. This all regular. What is this? Processor info. Okay, which extended features are we going to include? Oh my god, I hate how they have all these different bits for the AVX 512. It's kind of crazy. Hardware transactional memory. I feel like a bunch of this stuff like the hyper-threading is stuff used by the operating system that we don't really need. Built into, they allow user level, find private regions of memory whose contents are protected. This is for like DRM, I think. Decrypt it on the fly within the CPU. Okay, yeah, basically your web browsing, civil rights management. Nope, don't need that. SHA might be, or will is probably a good one to use. Okay. Bit manipulation, instruction set, AMD's Jaguar. That lowers bit. Interesting. This is stuff that's used by the compiler that I don't need. So I think AVX2 what is, oh, that's PKU. Third bit manipulation. Intel processor trace. That might be useful. Detailed trace. Capturing information about software execution on each hardware thread using dedicated hardware facilities. Loop behavior onto back edges, loop trip counts. Teaching flow reconstruction. Okay, I might include that just for shit. Oh, you know what though? This is all stuff that just having the CPU ID here, people can just check themselves. So really, I just need the AVX2. This is EVX. And oh, I'm wondering if changing this. From this right here, I and B. That's what we talked about earlier. Ooh. Well, here we are. I'm thinking of just changing this to register. And then this can turn into like EDX, EDX, EDX. This is probably easier to understand, or it's definitely easier to understand, at least for me. This is why I love macros in C. If you're doing complicated stuff like this, you can still do very complicated stuff and make it much easier to read. Let me see if that compiles. Yes, it does. There we go. So now, when I'm doing this, I can just look at this register directly. So it's EDX bit 5. For AVX2. Supervisor mode. Part of this I just love is seeing all the features that are in the processor that I just didn't know about. Fennec execution of non-privileged code. Yeah, this is something I don't. Commence wrap move. CID. Quality of service monitoring. VX512 foundation. Okay, here we go. What is memory protection extensions though? By checking pointer references whose normal compile times and intentions are maliciously exploited. New bounds registers new instruction set. Wow. Remarkable how much stuff processors do that most people have no idea about. Yeah. Multiple precision add carry instruction extensions. Contains just 2 instructions. Both instructions are more efficient. Adds 2 unsigned integers plus carry reading and carry flag. Wait, so does this allow you to do like 64-bit precision in 32-bit? I think that's what it does. Anyways, yeah, I'm reading this. Really all I need is this AVX and like the SHA. double word and quad word instructions. Double word and quad word. So let me check this. Oh shit. So you can see right here, this is AVX512BW, which is byte and word instructions. Okay. So you know what? Yeah, I need all of these, or it'll be very useful for all of these. RD seed. Instructions for returning random numbers. Oh, this will be useful. Astrophysical Monte Carlo simulator examining the time using RDRAND. They found a C implementation of RDRAND running about 2 times slower than the default random number generator and about 20 times slower than the Mercian Twister. Ooh, that's bad. But concerns RDRAND and pointed out it's not used as the only source of entropy, but rather used to improve the entropy by combining the values received from RDRAND. Wait, how is RDC different? RDC is similar, provides lower level access to the entropy generating hardware. Okay, we're going to include that because we included RDRAND here. Integer fused multiply add. We're just doing the abbreviations. I'm just thinking about it, this stuff's so complicated. Anyone who knows this is gonna know that like IFMA, FMA is fused multiply add, and they'll be able to figure out that I is integer because everything uses I to denote integers. I'm never gonna use this, but people can just check this bit25 if they want. What is the prefetch? Fetch the line of data from memory that contains AVX prefetch uses. Don't use them at all, let the hardware prefetchers do it. Still, it's possible. Calling and prefetching an address you'll need at some point in the future. It is similar in some respects to loading a value from memory and doing nothing with it, both from the line into the L1 cache, but the prefetch intrinsic, which covers when the covers is emitting specific prefetch instructions, has some advantage. The cache line granularity, you only need to issue one prefetch for each cache line. More is just a waste. That means that in general you should try to run the goal in your loop enough so that you can issue only one prefetch per cache line in the case of yeah, okay, that's what I thought. It's really not worth doing. These 512 prefetches really make me wonder though if when you're dealing with 512 bits, if the prefetch starts actually being that beneficial. Floating point elements starting at NV, packed integer indices. Oh, interesting. This actually loads from indices, almost like a texture. Or sorry, no, almost like vertices in a mesh. That's really cool. See, this is why I like looking at this stuff, just to know what's available. So yeah, I'll just include this because dimensional and reciprocal functions. Prefetches are pretty useful in specific cases. Yeah, I feel like it's just a question of time until you get until there's something where it's useful. Oh my god, there is lots of different ABX instructions. Conflict detection, wait. For equality. ABX512 conflict detection. Use them before traversing a tree. Oh. Conflict-free subsets of elements and loops that normally could not be safely vectorized. In practice, the example is quite inefficient, not better than scalar code. Compiler couldn't figure out what was going on. Yeah. Very advanced scenarios. Broadcast. Bit mask to byte mask. Parallelize. Counting leaving zeros. Conflict means existence of duplicated values in a vector. Instruction works on integer values, building positions of duplicates. Present at 0. At 0 and 1. Oh my god, that's so cool! Okay, yeah, I'm still including that because it's could be useful. That's intense. All of this is intense for me at least. ABX byte and word instructions. I'm nearly done these 32 bits. Vector length extensions. And I guess That's it. Alright. Now it's vector bit manipulation. VBMI. I also need to count how many flags there are now. 1, 2, 3, 9, 10, 11, 12. I don't know how to say, there's 14 of these. Fifteen, 14, 15, 17, 18, 19, 20, 21, 22, 25. 25 so far. I just said my code is ugly. I want to make people tear out their hair. Is that why you're bald? I'm just kidding. Galois field instructions. What are these? Implementing multiplication of Galois fields. Elements of GF can be represented as polynomials of degrees less than n over GF. Operations are performed modulo an irreducible polynomial degree. What the f— finite field or Galois field. Dude, how have I not read into these before? I probably have, I just completely forgot about it. Primitive polynomial. Interesting. Wait, AVX512 neural network instructions? What in the fuck is this? Wait. How have I not heard of these? Convolutional neural network multiplies individual bytes 8-bit of the source operand by the corresponding bytes 8-bit, producing 16-bit, which are summed and accumulated in— holy shit! This is exactly what I needed for my integer-based neural network. Oh my god, wait. VNNI. Block dot products of 2 signed 16-bit. Multiply groups of 4 adjacent pairs of unsigned 8-bit integers. This is it right here. This guy's been writing C for 4 years and he says my code is bad. Man, I wouldn't dwell on it. Me and you have both said this multiple times, but people are stupid. Oh my god, yeah, it sums them up. Holy shit, this is amazing. For adjacent pairs, corresponding signed 8-bit integers. Okay, wait, where's the 512 version of this? It's 4 adjacent pairs of 8-bit integers. Oh my god. Holy shit, wait a minute. 512 divided by 8, that's 64. This doesn't add up. Groups 4 adjacent pairs. Sum these 4 results. Corresponding 32-bit integer in source. So, wait. This isn't the function. Does this really... Wait, this doesn't seem that much better. The second source. We get 16-bit, which are summed. Our repeated multiplication of 2 16-bit values or 2 8-bit values. Okay, so I think the main part here is actually the saturation. But what I don't understand is if it's a 512-bit word, then divided by 8 bits, why isn't there 64? Because the whole thing I'm looking at with this, only supporting 8, or only supporting 16 here, is 16 is exactly how many I would get as if I used, or I would get 32 if I did 512 with 16-bit. So this is why I don't... Oh my god, I didn't realize this. Of 2... So this is actually looping 15 3 times. Holy shit, these instructions are so complicated. But this is actually going to be key if I'm going to be optimizing. Actually, let me just show, I think I still have it here. LearningMachine.js. This is an integer-based neural network I programmed to test integers instead of floats. And integers best loss of 0. Basically, the quantization from integers, this is a neural network matching a triangle wave. The quantization helps evolution and the training so much. So this has now shifted my whole focus towards doing these tons of tiny 16 or 8-bit integer operations. This is just a shitty example in JavaScript, but the real amazing thing is if there's these AVX512 neural network instructions, if this can actually do 16 times 4, 64, like, this actually looks correct. This is does seem to be the 64 instruction I was talking about, so we'll see. I'll have to test these at a different time. I didn't even know those existed. I'm very happy to find that out. This is why it's good for me to just look through this list of instructions. Man, they're starting to just do bit flags for every single AVX instruction. That is kind of annoying. Four-register neural networks, four-register multiply, simulation, simple precision, speculation, part of indirect branch control. Ooh. Okay. We're just about done. Damn, that guy wrote a lot. Alright, I think that's good. 14, 15, 16, 17, 18, 19, 20, 21, 22. 28, 29, 30, 31. 31 flags. So then we gotta declare all of these. Alright, we're like halfway through. We're right here. Just trying to do this as quickly as possible. And here we go. Last one. 4F maps. Boom! There we go. Okay, let's test this. Now I need to do this exact same thing here. And actually right here I can just replace DCS with PS, since I'm using macros for both. And that actually should compile right now, because the way C works, it should just ignore, just ignore the other arguments here, but for making it pretty, I'm gonna delete these. And that's a funny thing you can do in C. You could just make do a bunch of code with macros and just add a bunch of arguments that aren't even used. And if people are trying to read your code, it would just throw them off so much. Oh my god. Is it like, I've actually, man, there's been stuff in this engine that I'm gonna release, but I've wanted to like hide from people, and this is making me think. Okay, let's see. MMX available, DCA not available, AVX2 available, AVX512 Foundation not supported, RDC not supported. Basically all these aren't supported. Let me check. Let me make sure this actually matches up. I have a pre-processing step that wraps all functions in a macro and adds extra parameters to the end. Yeah. Alright, we're checking to make sure. Does it say? AVX2. It doesn't say AVX512. I think it's correct. I think that's actually correct. I don't have AVX512 support. When did AVX512 come out? .4x series. Yeah, no, it doesn't include the i7. Okay. Oh wait. No, okay, so it doesn't include my i7. I think last year. Yeah, alright. Just making sure if this matches up. So this does match up. Intel, it does say I have AVX2 support, and Intel this Intel card does have AVX too, so there we go. Correctly queries what is supported on the CPU. I'm just super happy to have this done, because like then whenever I do want to use these things, I can just easily check these bit flags. And actually, wait, 0, 1, 2, this should actually be 32, not 31. But it doesn't, oh, so that actually didn't make a difference, because this is rounded up and aligned 8 bytes, or 8 bits, so that 31 was rounded up to 32 anyways. At least like in the memory buffer. Alright, so there's another example. There's an example for CPU ID. What is the compression? I'm just gonna go through here. Because I've changed a bunch of the code and haven't updated the examples, so like this compression here doesn't match up. So I'm going to change that. Is the source for this engine online somewhere? No, that's what I'm preparing these examples for. Yeah. When I put the code up for this, it's not just like people shooting in the dark. Alright, we're gonna do this compression example. Because this is another small, easy one to do. Oh wait. Also, do I have build anywhere here? Build.sh. No, I have it right here though, right? Oh no, where is it? I'm supposed to have a build script for Linux here. Oh shit. Did I delete it accidentally? Oh my god, I'm a dumbass. So the idea is that the Visual Studio projects here in the examples are how you compile it on Windows. But on Linux, it's just going to be a shell script that just runs GCC. So you can just run it from the command line here. And I was supposed to have those, but apparently I don't, so I guess I can just go through and copy and paste them in afterwards. That's part of the reason is each of these files starts at main.c, is that way I can use the exact same build script. Or each file only has a single C file and then includes headers. It's so that you can just compile this as easy as possible, because I'm a person that fucking hates dealing with all the different C libraries and dependencies and things. And as soon as you try header-only libraries, you never go back. It's like a fucking addiction. As soon as you use header-only, you start realizing how bad DLLs and dynamic libraries are. Anyways, this compression here is run length encoding. source, destination length, base. Oh yeah, bigger base makes compression less. Oh man, so higher base decreases the probability chance of compression, but also decreases the probability of inflation. It's so complicated. If the base is low, you can end up actually making the data larger rather than compressing it if you don't have any repeating data. But then if it is repeating and the base is low, it can compress very well. See, this stuff's so complicated, you almost like can't describe it with comments. You have to actually understand how the math is working. Anyways, we'll just do a base of 1. Let's see, yeah, 1 to the power of base. Comments better serve the block at the top describe the algorithm. Math is pretty self-explanatory. Yeah. Multiple bases and using best result. Alright, and then this last part compares the data to make sure it's actually equal. Compressed 4096 bytes into 1936 bytes, 100 to 47 compression. So that's basically 2-to-1 compression. That is very nice. So that's a nice simple example, I think. And let's try lowering it. Oh yeah, so 0 doesn't work. Yeah, so higher base has less compression. Base is 1 to 32. Kind of compressor to the right. It's binary run length encoding, so it compresses repeating ones and zeros. Between 1 to 32. Higher is better. More random data. Alright. There we go. So that's a nice little example of the compression. Let me see if this compiles without system. Yes, it does. Okay. Boom. So just to actually do a bit of cleanup here. That also means that these other examples like list, I can remove system from here. Actually, let me try this. Let me make sure. It would be stupid of me to remove this code and then not check if it still compiles after removing it. Okay, it does. Compression, CPU ID, database. We're just going to go through and we're going to make sure all of these work and run. Example data, array of C strings, stored database in memory, create database for storing C strings, put data map in memory. Look up C string, database ID. Yeah, so this is like a file-based hash map database. Oh my god, all of these are compiling. Oh yeah. Feels good, man. Data storage. Oh, it doesn't work though. Oh wait, yeah it is. So this prints out data storage and lookup by looking them up in the database using a data map. I bet he doesn't even program. He probably writes more comments on Reddit than he programs. Alright, this is basically the same code except with a hash map. Instead of, so data map in my engine, data map is a hash map that runs through a stream. So you can store it in memory with like a memory stream, or you can store it in a file. But hash map is optimized for 30. It's like it's supposed to be extremely fast, uses 32-bit integers. Testing hash map lookup example. Alright, that works. For some reason on one C server people like it, on another not so much. Yeah, that seems to that seems about right. That's how it works. I just want to go to sleep. Oh man, I need to not sleep. Oh, this should be interesting. HTTP GET utility, console-based HTML text viewer. Enter URL. Okay, I guarantee you this isn't going to compile or it's going to crash. I'm fucking calling it now. This is complicated and it's not well documented. I didn't really sleep last night. I slept like 8 hours. You get to that point where like you're so tired that you're not tired anymore and you can't sleep. New INET address, too few arguments. This isn't documented either. This isn't a good example. Yeah, I feel like this isn't a good example because it's way too complex. Yeah, I hope you do have a good sleep though, said who. You know what I'm thinking though? It's probably good to have some complex examples that actually show like a full app. What's changed about this INET address? Oh, there's two booleans at the end. One is IPv6 and one is TCP. Oh, I gotta include WinSocket lib. Actually, say this here in NSocket, I believe. It requires linking with AWS. So this is things that I think are key in my library, is I don't have a lot of documentation or comments, right? But if you ever try and compile my library and you get linker errors, if you go to the headers here, I have written which libs you need to include. So I've just realized I've only got these working for 64-bit. Gone for real now. Have a good one, said who. These are only working for 64-bit, so I actually might need to go through and change all the Visual Studio project files for these to actually work on 32-bit, but we'll see. Alright, HTTP GET utility, console-based hit quit to stop. If you want to view an local HTML file without downloading, enter file. File main.c. Failed to read file main.c. Hey, Blue Dynamite, yeah, you can ask. Feel free to ask away. Alright, let's try a basic URL. I bet this doesn't work. Received 404. Index.html. Sales.com. 404. Huh. How to represent literal as an integer value 0. Okay, what type of literal? It depends what language. Hold on a second. Okay, yeah, something is... This HTTP might not work. Sales.com, response code for received. Probably failing to create the socket. Yeah, just setting it to 0 should work. Oh, yep, it's not even creating the socket. Not even creating the INET address. I should actually test these end-socket examples. I'm working on actually programming. This should just be true for IPv6 and TCP. I will try false though, let's see. Trying to x equals 0 and it's not working. I have no idea then. Yeah, whatever specific error you're getting would help a lot more. Okay, so I actually don't think this new INET address, I think I changed this around, and it actually doesn't use a function that parses domain names now. Let me see if this resolves domain name hosts. Convert domain names. Not resolving name. I expect identifier X. There's no need for a semicolon here. Try just putting in 0. It worked just 0, thank you. Man, I'm having flashbacks to these few stupid Python programming things I had to do for school that had stuff like that where, yeah, Scallywag, so I'm guessing it's like this online compiler that's made to make you test, like little tests, unit tests, and they normally are like badly programmed themselves and have super stupid little things like that. AF unspecified. Let me see this. Does AF unspecified fix this? I would not be surprised if it did. Nope. Pending index HTML is not on purpose. Yeah. Index HTML is the file here, and the Zalos.com is the host. What's happening here is though is it's failing to even create this internet address reference. Or yeah, initialize, get this address info, which is yeah, I don't know why it's not even able to create this. It should be able to do get address info on that, but I guess not. What language do you guys recommend for games? I recommend C. That's why I use C. C is the way to go, but it's a long night. See, I think C is pretty simple, which almost makes it easier. Success returns 0. Either a service name or port number. Service name is a string alias. For example, HTTP is an alias for port 80. Let's just have this output. Port 80. Yeah, shit, maybe it needs to do HTTP. These languages are allowed to do basically anything, so you just got to make sure you don't do dumb things like read memory from locations you shouldn't. Yeah, that's part of learning though. I think that's part of what makes you learn faster. Sales.com. Return value 10,093. Oh my god, if I'm just not running WSA startup not yet performed. Holy shit, wait a second. Init and socket system. Init. Oh my god. I never initialize WinSocket. Fucking dumbass. Okay. Oh my god, if it works now... Hold on, wait. Let me just go back and undo all the little changes I just went and made. Let's just go back to our old code. Try it with IPv6 as well, since that has backwards compatibility. Okay, so now we're exactly back where we started. Okay, no, it still failed. So we'll still output the result right here. Oh, we got a different error now. Host not found. Okay. Let's try www. So I think I'm not sure. Let's try AF unspecified and maybe do HTTP port. Get a sub button and stuff. Well, I'm not sure. I've actually wait, you got an ad? I thought Twitch removed ads for people like me that weren't affiliated or anything. So that's actually part of the thing. I thought that if you didn't have a sub button and you weren't affiliated, you didn't get ads, because I'm not like, I have so little viewers. I guess that's not how it works. Huh. Oh shit, here we go! Response code 200 received, parsing text. Oh my god, look at this. What fixed it? Where is it? This right here, AF unspecified. I don't think I need to say IPv6. That'll actually be a thing that'll be interesting to test. The question: qualifying an integer declaration with unsigned increases the maximum value by a factor of normally like ×2. I'm actually thinking, what's a I could do a bit better of this, removing all these new lines. Yeah, there's so much stuff I can do to this. One of the things I'm just looking right now is like, is this unspecified going to work if you're hosting a server as well? Like with this example, I'm almost thinking I should do this example right here before the HTTP example. Because this is like a simple message system. I'm gonna go talk to this cute girl streaming. Have a good time, Blue Dynamite. My stream's actually almost over anyways. I'm getting really tired. I will be back tomorrow. Also, I keep talking about this stuff on Discord after the stream ends, so there's always that. Alright, let me see. I'm just gonna go over to this socket example here. And we're gonna try these. We're gonna see if these compile. Oh, I forgot to include the WinSocket library as well. Where are you from? I'm from Ontario. BC. Very nice. Pretty good, except I have 110 bacon. Ooh. It's okay. You got Peeker's advantage. Ooh. I didn't do that right. I forgot a semi-quote. There we go. Alright. So we got a server and a client. So if we start up the server, please enter the port you would like to host the server on. We're going to do it on 9999. There we go. Server's online. Please enter the host name of the server. I believe it's this. For IPv6, attempting to connect, received connection, connection established, received connection. Oh, and it disconnected. Okay, so first of all, this is super good. This means this works with the unspecified. I'm actually curious if I take this to Linux, if it'll fail. I swear I ran into issues with this before. But it seems to work. Anyways, this server crashes. Received connection. Oh, so this message to the server. Wait a minute. I'm just writing this quickly. And socket right. Okay, this should work now. So I actually didn't have any code in the server. Hello world. Hey there. Message from server. Hello world. Message from server. Hey there. Okay, so this is a really bad chat program that only sends messages when one of them sends a message. But boom, there we go. that's basically what I wanted to test though, that everything still worked, even with the unspecified. And one thing I want to see is if this is unspecified, can I actually connect to the IPv4 as well, or just IPv6? No, so I can't connect to IPv4. Let me see if localhost works. Localhost works. Interesting. This is all really good stuff to test. Honestly, like, I think I knew this stuff and I've just forgotten it. Oh man, there's so much stuff in computers. Either way, these examples are so good to have, where you can just go and look at these reference points of how to program like these key things, like basic client and server. I'm gonna fix this up tomorrow, and I think I might redo the HTTP one. I don't know. We'll see. I'm getting tired now. That's part of the issues, and I don't feel like I'm thinking clearly about, like, I can't really make clear decisions on where to go with this, so this is the time for me to end up. But I'll be back in tomorrow. Gonna be streaming. I'm gonna try streaming, like basically stream every day for a month. Already been a few days in, and a bunch of people seem to be loving it, so thanks so much, guys. Like, that's amazing. I've had a few friends come in that I haven't talked to for a while. Keith, stuff like that's great. So yeah, thanks so much, guys. Thanks for stopping by. I'll be back again tomorrow. I'll see you around. Thanks so much.